assay, we have 3 picket. 1, 2, 3. Okay, this is important. We need to do 3 picket so that we get consistent. We want to see which one is, the consistency of the assay that we did. Okay, so let's just see each other by observing from your naked eyes. You can see that the color of the turbidity of the green color is different. Okay, they are different between each other. And then let's just see the absorbent for each of them. So for tube number 1, yeah, it is 0.204, and then for tube number 2 is 0.92, and then for tube number 3 is 0.199. Okay, you can see here that tube number 2 obviously is outliers. It's not from, it's totally out from this string reading. Okay, that's why we suggest to just remove the tube number 2. Okay, unless there are 2 tubes having 0.0 and only 1 tube having 0.199. So this one will be out. If these two showing 0.0, 0.085 or 0.095, and then this one suddenly 0.199, we exclude this one because this is too different than between these two. Okay, so we don't want this to be the standard deviation, the error bar is big for this sample. Okay, so there's one group they calculate for the standard deviation. I can share that one that result with you later. Okay, so since this group they have decided to take only 0.2 and this one, and then they take the average. So the average for the absorbent is 0.2015. Okay. Okay, for the control, we did also 3 picket. Tube number 1, 2, and 3. Okay, and then we see the reading for the control. They're not too much different between each other, but still the first one is like 0.014. The other two, they are really close to each other. So maybe we want to exclude this one. Okay. But doesn't matter if you can see the control is 0.0, I think it is good enough. It's suitable to become a control. Okay. You don't want the control turn out to be green color. So that's not so good. There's something happened. Maybe you mix up the tube or similar tips has been used to take the sample and then to take the same, the buffer for the control. So that's why it turns out to be green color. It's supposed to be colorless. Okay. So for this case, this group has taken 0.075 and then 0.077, and then took the average. It turns out to be 0.076. Okay, so now we have the average for the control and then average for the sample. Okay, let's just go for the calculation first. Okay, so how do we calculate for lipase activity? We have here average of the average OD of the enzyme and then average absorbent for the control. We have here 0.2015 minus 0.076 because we want to know only the absorbance for the lipase reaction. We expect this absorbent comes from the background, so we want to minus this sample with this one so that we get the real absorbent for the lipase assay. So for this one will become the Y value. So in our standard just now, we have here Y equal to 0.0191x plus 0.0343. So it is standard equation for the straight line, y equal to mx plus c. So this c is the y-intercept. This x or m here represent the slope. Okay, the y is absorbent from here. You need to know later. Okay. So now we have the reading here 0.1255. If we go directly to this 0.1255, 0.1255, basically it will just supposed to be here 0.1255. We go down and then this one will be our x value. Okay, so it should be less than 10. Let's just see down here. What is the x value that we got if we put it in the equation? Yeah, you see we have got 4.77. So it is less than 10, right? I repeat, absorbance says here 0.1255. 0.1255. And then we go back here, check 0.12. 0.12. Okay, supposed to be this, right? Okay, and then if it is 0.122, 0.12, so this one will be the value of the X. I mean the micromole of fatty acid. According to this scale, we know the biggest here, I mean this point will be 6. So if it is here, it's logic. If you have the value here is 0.4 just now, it's logic, right? If we take directly from the graph. That's the purpose of having the standard. Okay, so now we have got 0.4 based on the calculation. 0.4, then it's logic. So if we calculate based on the calculation, we can see here, okay, 0.1255, if put it in here for the y, okay, this is the absorbent 715, and then put it into this equation, and then get the value of x, you get this. So remember, this 4.775 here, macromole of product is basically for the 20 microliter. Okay, remember your essay just now. Inside this, what do you have? Inside this, you have put 20 microliter of enzyme. Okay, the crude enzyme. Okay, and then we have also put what was the time? You have essay for 30 minutes. Okay, 20 microliter of enzyme of the crude enzyme, and then 30 minutes. Okay, then the absorbance, I mean the macromole product, okay, the free fatty acid release was 4.77 micromole. Okay, so this is what does it mean here. So based on 20 microliter of the crude enzyme within 30 minutes, because we have done the essay for 30 minutes, right? Okay, I'm going to scroll up. If you can't remember where does the 30 minutes comes from, okay, yeah, here, okay, you have incubated for 30 minutes here. Okay, that's why this 30 minutes. Okay, 30 minutes, 30 minutes, 30 minutes. And then the volume of the sample you have taken 20 microliter of the crude enzyme. 20 microliter of the crude enzyme. Okay, so 20 microliter of the crude enzyme, 30 minutes. Okay, remember the time and at the time taken and then the volume you have used for assay. Okay, so now okay, so we go back to the absorbent down here. Okay, so this one 4.77 because of the reaction. Okay, what do you mean by reaction? Crude enzyme, I mean the lipase, again I will okay, this the crude enzyme, this dot. Okay, the crude enzyme, the lipase enzyme, this light blue enzyme react on the triglycerol, right? The triglycerol just now, okay, releasing the free fatty acid, okay, the triglyceride, okay, this triglyceride, okay, okay, so this is the enzyme react this triglyceride, and then the amount of the free fatty acid released is 4.77 micromole based on 20 microliter of the sample, 30 minutes of the reaction. Okay, so now if you still remember the thing that we discussed in the earlier, the unit definition is for 1 minute, right? Unit definition, the reaction within 1 minute. So, but we have here 30 minutes. That means this product need to be divided by 30 minutes. So this product 4.77 micromole is because of the 30 minutes. So we need to know the product release within 1 minute. We don't want within 30 minutes. So that's why the that's why we perform here 4.77 divided by 30. Okay, 30 minutes here. Okay, so the result will be 0.15. 16. You can see here the result here. So free fatty acid. I don't understand. So the free fatty acid, release for 1 minute. Okay, within 1 minute, not for 1 minute. Within 1 minute. Within 1 minute for 20 microliter enzyme is 0.159. Okay, micromole. Okay, so now you have got this one. Okay, so within 1 minute for 20 microliter of enzyme, it is 0.19 micromole. Okay, so what's next? Enzyme assay or enzyme activity. Okay, enzyme unit, you know the definition of the unit. Okay, unit definition, fine, you got it. Okay, so got this. Okay, done previously. But we need to know enzyme activity. Okay. 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 Enzyme activity. Enzyme activity in unit per min. Okay, so every time we read about the enzyme activity, they express the amount, the rate of product released within 1 minute in 1 minute. Okay. Okay, so the rate of product released within 1 minute in 1 minute. So meaning that we have done for the 20 microliter. Okay. So now we know that if 20 microliter is equivalent to 0.00 is it 02 mil. Okay, 20 microliter is basically equal to 0.02 mil. Okay, so now we have here 0.159 is for 20 microliter. In order to know for 1 mil, we need to divide with the volume. Okay, so as you can see here, okay, as you can see here, this 0.159, okay, we divide with the volume of the sample. So the volume of the sample is 20 microliter. So 20 microliter is equivalent to 0.02 mil. Okay, then we get the value for, the unit activity for the 1 mil. 0.159 divided by 0.02, and then we got the result here. Okay, the result here 7.96 unit per mil. Okay, if you get confused this step, why suddenly you divide by this? You can do it slowly and really manual. Okay, how? Okay, you can just calculate. Okay, 0.1592 okay, divide by 0. Okay, divide by 20 microliter. Okay, divide by 20 microliter. That means this is for 20 microliter, right? For 1 microliter. So let's just grab the calculator. Okay, not grab the calculator. Okay, let's just grab the calculator here. Okay, 0.1592 divided by 20 because it is 20 microliter. If you divide by 20, that means you got the result for 1 microliter. Okay, this is for 1 microliter. Remember, we need to make it in 1 mil. So we need to, this is micromole of product for 1 microliter. We need to multiply by 1000. Okay, because 1 mil is equivalent to 1000 microliter. So if we multiply by 1000, we get 7.96. It's similar. So I make it short. We divide with the volume of the sample, where the volume of the sample we have changed to mil unit. Okay, so we just need to have the micromole of product for 1 minute divided by volume of the sample, which is 0.02, so that we can get this unit per minute. Okay. Okay, so that's it for the enzyme. Okay. So do we have any questions so far before we move to the protein assay? Let's see. Stop sharing. Any questions so far? Why I can't see any chat? How do we check? Hmm, this is the chat room, right? Okay, no, okay. So we will proceed for the protein assay. Okay, before that, we will see the standard deviation. Okay, standard deviation because of the things here, which is, the big difference between these three will give you big standard deviation. So let's just see the other lab report. I think this one, maybe. What is it? No, not this one. Which group get the standard deviation? I can't remember yesterday. Amir Rahim. Anyone, please tell me which group has prepared the standard deviation? I can't remember which group yesterday. I've checked yesterday, but I can't remember. Okay, this one. Yeah, this one. Okay, I'm going to share the screen now. Okay. So this is the one. Huh?
Ada soalan dekat chat.
Stop sharing, right? Mana? Where can I get the questions? I don't know how to see the question. Okay, this one. Okay, I need to make it bigger. I can see from here. Okay. To be confirmed, the free fatty acid will include the oleic acid and other fatty acid too. Yes. So we are measuring the free fatty acid, even though our standard we use oleic acid as the standard, but when we do the lipase assay, the role of the isooctane there is to capture all the free fatty acid. Okay, so that means we are measuring the absorbent we are taking now is the free fatty acid that being released from this reaction from the olive oil. Okay, so it's not only specific for olive acid, all other free fatty acid. What is the difference between specific enzyme activity and enzyme activity? Yeah, we will go for that once we have settled with the protein assay. So that the final one we discuss about the specific activity. Okay. Okay. So I will show this one first for the standard deviation. Okay, so this standard deviation. Okay, so if we look at here, we have sample 1, 2, 3. Okay, number 1 is 0.0. It's almost similar to how I'm going to close this. I'm going to open again. I'm going to use different color. Okay. So this one 0.063, 0.141, 0.555. Okay, so this you can see the difference between this, and this. They're really huge. Okay. Normally for this kind of data, I would suggest just prepare the new one because you don't know. You want to say that sample number 1 and 2 they are closer to each other? No. I believe sample number 1 will not give you any color. I mean any grain turbidity. But sample number 2 will give you some. But of course sample number 3 will give you quite intense green color. Okay, so for this one, that's okay. They have decided, this group has decided to take sample number 2 and 3, then they get this average. Okay, so the good thing is they have calculated the standard deviation for all, for 3 of them. Okay, and then for this standard deviation, you can see here, this is what here, 0.2159. Okay, as for control, same here. I don't know what happened to this first tube. 0.063, 0.57, 0.064. The reading here, and then they got the average of 0.61. They're quite close to each other. So that's why it gives you the standard deviation is really small, 0.0031. So that means this is good. So when you have a big difference, that means the standard deviation will be bigger. If you have, consistent reading close to each other, the standard deviation will be lesser. Okay. Okay, we continue with this one, I think. Okay, this is the folic acid that we are talking just now for the standard 0.63, 12.6, 18.9, okay, 25.2, and then we got it. Okay. And then the absorbance, then this is what we get. Okay, this is what everyone has done last time. And then same here, they have got 0.348 minus by the control, and then they got this absorbent. They put this absorbent in the y equal to mx plus c, and then they got this. Okay, if you go directly if you go directly from this to this 0.287, 0.287, 0.287, there must be somewhere around here, and then we go down here. This is the value of x. It's logic, it is 13 point something. Yeah, but this is 20. So that's the way. And then after that, we go for enzyme unit, enzyme activity. Yeah, they have calculated correctly. Okay, so 12.3 micromole, 3.23 micromole, put it in here to get in the unit. And then after that, you got the final one in unit per mil, 22.05 unit per mil. Okay, so we're done with the enzyme assay. We move to protein assay. Okay, we move to protein assay. So last time, what you did, you just prepare the standard. I don't know which one the standard here, but I don't know which one the standard, seriously. Anyone can tell me from your experiment last time, we share this thing, right? Oh, I think all of you prepared the standard. Yeah, all of you prepared the standard, yeah. Okay. Okay, so, okay, maybe group 1 we focus on this side. We focus on this side. It looks continuous. I mean, the intensity of the blue color is increasing. Okay, so for this one, the first tube, the first well, okay, the first well is the Bradford protein assay. Protein assay is the assay method which used to measure this. Okay, the other proteins, okay, in the crude sample and the lipase. Okay, the lipase protein. Okay, same here. The protein we use BSA as the standard. Okay. Okay. What is BSA? BSA protein standard. Okay. Protein standard is bovine serum albumin. Okay. Okay, bovine serum albumin. Okay, a solution protein used for reference for protein assay. Okay, so now BSA is a protein. So in this protein is a mixture of a few amino acid. Okay, a mixture of 20 amino acid. You can just put it that way. So this BSA basically will be colored, okay, by the Bradford reagent, so that it give you the different intensity of the blue color. Okay. So are we okay? The question here, do you think our protein is also are we extracting? Okay, the question here, are we extracting protein sample from bovine? No, right? So, but still we use this bovine, BSA as the standard to measure the protein. Okay, that's why we need to mention in the method we use BSA as the standard to perform the protein standard. Okay, so because logically, why you have the protein from E. coli? Why do you need to use a standard from bovine, which is different source? This is from mammalian. E. coli is from microbe. So there are two different organisms. But now we are focusing on the protein inside. We have the amino acid inside, and then we have the peptide bond to link all this protein. So basically, it is sufficient, and BSA has been widely used as a protein standard. That's okay. Okay, if you relate back to our lipase assay just now, we are measuring any free fatty acid, but our standard is only for oleic acid. Okay. So now we can see here that this section is the result. Okay. 1, 2, 3, 4, 5, 6. These 6 were they are the standard, starting from 0 microgram of protein. And then you start putting 4 microgram of protein, if I'm not mistaken. 4 microgram, 8 microgram, I think. 12 microgram. Yeah. Is it correct? Let me check. Yeah, we go back to your to the table. Okay. You see the table here? You have put a standard protein. Well, number 1, no protein. Well, number 2, amount of protein. Yeah, this one. Macrolate, we don't want a macrolate, we want to have this. Okay, so that means we have used this amount of protein. we have used this amount of protein. Okay, so 2, 4, 6, 8, and 10. Okay, we go back down here. It is 2. Okay, this is for 2. Okay, you have here 0, and then 2, 4, and then this one 6, 8, and 10. And then these two, you don't know. These two, question mark. Okay, so as we increase the blue color is also increasing. So you can see here, if you put nothing, nothing means that 0 amount of the protein, 0 amount of the BSA, there will be no color. I mean, this is the original color of the effort region. And then if you put 2 microgram, and then you start to see some blue color being changed. Okay, 4, 6, 8, and 10. Okay, now this is your standard, and then we have your sample here, which you don't know. You don't know the 2, one with 20 microliter, one with 10 microliter. 10. Okay, if you put 10 microliter, I mean, if you put 20 microliter here, maybe the absorbance here is more than the 10 here. I mean 10 microgram. Okay, I repeat. Why you put here 20 microgram? Okay, and here why do you put 10 microgram? Because the maximum volume will be 10 for the sample. But you don't know. If you use 20 microgram in here, and then turns out the absorbance for this like this. Okay, if the absorbance is just like this, and then this is darker than the 10. If this one, the absorbance for this is more than whatever available in the standard, you cannot put 20. Okay, meaning that it is excess of the protein. Okay, excess of the protein, you do, and then it is exceed from the standard. The standard can no longer be used. Okay, so if you use 10, and then it turns out to be this color, and then it is within 2 microgram to 10 microgram, then it is a good choice when you use 10. You can even end up putting only 1 microliter of the protein sample plus 19 microliter of the water. You can put 5. If you put 5, you should put the distilled water 15, because you want to make it the total volume. Yeah. So later we will divide with the volume of the sample that you have taken. You will multiply this so that you get the 20. Okay. Whatever happen, we are adjusting this volume of the sample so that it will match with the concentration that we have in the standard. Okay. So now we check on this group. Okay. I notice majority or many of you has done this, which is incorrect. Okay. Okay. Logically, you have put the first sample, I mean the first well with 0. Okay, 0 volume, 0 amount of the, yeah, just now, 0 amount of the protein. Okay, zero amount of the protein, meaning that this well number 1 is for your blank. Okay, how come blank give you some absorbent? Because it is meant to be zero. Blank means you read zero, you make it zero. Sorry. Okay, so how come blank give you the absorbance up to, wow, 0.2 0.24, I think, which is huge. It's supposed to be zero. Yeah, no, you have got this one, 0.314. This is so weird. Okay, so yeah, it is not supposed to be like this because this one is so, yeah, it cannot be. Okay, this one, yeah, zero is supposed to be zero. So zero, whatever reading from here, you need to minus by this. I don't think this is a good protein standard. Okay, if you find that this thing is funny, okay, this one is supposed to be zero, and then this is your real absorbent when you put 2 microgram. 0.159 minus 0.314, that means it is zero. This one will be zero. Then will be your standard will be zero, zero. This one also zero. This one you get some little bit of absorbance because 0.32 minus 0.314. Okay. If this one minus this, you can get at least 0.06. 0.006 is also not logic. So it will be like somewhere around here. Right? If you plot the new one, it will be like this, and this. Because this one should be zero. This one, if you minus this, it give you negative value. That means it's zero. So 0.22 minus by this is also zero. And then this, you will get 0.06, right? Yeah. 0. No, it's not 0.06. It will be exactly 0.32 minus 0.314. It will be 0.006. Okay, it is not here, but it will be 0.006. It's somewhere here. It's also funny when you have one something there. And then this one also will give you negative, because this is